Yo, this is Ali from the AI Enthusiast guys, and today we're going to be starting the question answering software guide. So this is going to be a series of lectures where I'll be going over QA, general QA techniques, and then we'll be going into actually coding, and we'll be covering some architectures. And then, yeah, you can follow along. You can also look at all the code. It's on GitHub, and we can get started. Okay, so we have three types of question answering. The first is extractive QA. So basically, you have two inputs. You have the question that you're asking, which is a string type. Then you have the background information. We call that the context. And this is going to be a large string that's going to have the information that we're asking the question about. The result is then going to be a substring of the background information, aka the context. So it has to be an actual substring, like a string found within your background information. Open Generative QA is going to be that the result, it's basically the exact same thing as extractive QA. So you're going to have a context, you're going to have a question, but the model is going to generate free text directly based off the context, which is like the background information. So essentially the result, it's going to have a portion of the context, but then it's going to build on top of that and generate new text. And then finally, we have closed generative QA, which is basically we don't even have a context. We don't have background information provided. You just have the question. You ask that to the model, and the model will generate the answer on its own. So again, the three types, extractive QA, you get the substring of the background information you provided. Open generative QA, you're going to get some substring, you might get some information from the background information string, like the context that you provided, but it's also going to build on top of that. And then finally, closed generative QA, it's just going to answer. There's no context information provided. Okay, so when do you use which? So here's some scenarios and some criteria. So the first one is, do users actually need to read the text, the context string that you provided? So imagine you have a standard operating procedure. Uh, questions are being asked related to the standard operating procedure. So then you can basically just point the user to whichever section you want to point them to based off of the question that they're asking. And then this will be the most effective way of answering the question, and you don't have to summarize this SOP because there might be details that the model will miss. Then you have criteria, second one, where you have essentially like if the document provides an answer, but the answer could use some additional background information. So when I say document, I mean the context string. An example of that is going to be historical texts. So the answer might be a particular event that happened in time, but then the background information provided doesn't actually give enough information on that event in particular, so you can add some more context. Then we have the third criteria. So when users are asking questions and they're spanning many different fields, so maybe there are questions in engineering, maybe questions about history, maybe questions about psychology, what have you. And it might be easier to just use a closed generative model that's been trained on many different uh, corpora of text. And so this is, the scenario here that you can think of like a search engine. And then, you have some considerations here. So extractive QA and open QA, their open generative QA are going to be using the context string that's provided, the background information. So if there's a lot of background information provided, you're going to have to chunk that up. And I'll go over that at a later lecture, but basically it's going to add complexity to your design. Then you have the closed generative QA. So, these models are going to be larger, they're going to be more expensive to train. Fortunately, you can use open source models, but still you have to read up on their licenses, and then you still have to manage the usage of that large model. Alternatively, you can open source that and you can call an API, but that's going to be expensive, and it's going to, there's design considerations for that as well for your software. So yeah, let's move to the next slide. Yeah, so I just realized we're at like 5 or 6 minutes for this video, and it's going to take time for me to go over like this and then go over the code as well. So I'm going to break that out into a separate video. I just wanted to show you guys. So this was the introductory video on question answering. So this is the concept architecture. This is the first iteration. Next video, we're going to go over extractive QA. We're going to go over this particular diagram, and then I'm going to show you how we do this in the code. And then the next video after that, we're going to go over open generative QA, and finally closed generative QA. So yeah, stay tuned. And then of course, these are just concept architectures. Then we're going to be talking about like actual software architecture, some of the things that you have to do, like for example, use a vector database, and then how do you scale that? how can you add caching potentially. There's all sorts of things to talk about to actually make a full-fledged web application, or just any general application that would use QA. So yeah, thanks guys. I'll catch you in the next video. If you like this video, please like and subscribe. It really helps the channel. And if you have any other questions or comments regarding this video, please post them at the bottom. And take care. See you next time.